From the previous video, I delved into byte versus signed byte, and we can see that the signed byte covers a different range of numbers versus the byte, which covers a positive range of numbers. That each type is still 8 bits, thus they can store a maximum of 256 values. The difference between byte and signed byte is, are we going to represent the negative values as well? We're going to shift that 256 value range down into the negative zone, or are we going to push it all into the positive zone by just saying byte? The concepts are still the same for ints, longs, and shorts, except your range is much larger depending on which type you use. Okay. Now, something that was really frustrating to me as a new programmer in C# was I was coming from C++. And C++, at least back then, C++ would kind of let you do whatever you want to as far as these types are concerned, and it would figure out what you were trying to do and just do it for you. It would implicitly convert one type to another. And then I moved to C#, and I tried to use my hackish C++ programming techniques in C#, and C# would always give me an error and say, I won't do that for you explicitly. You have to force me to do it. And it was extremely frustrating, but let me illustrate here a little bit. I'm going to say byte num people in family. Let's say the number of people we have in a family is 16. Rather large value, and nothing to do on the weekends. And then I'm going to say signed byte, signed version gets num people in family. Now, as a C++ programmer, this made complete sense to me. It just seemed like this should work. All right, why are you complaining? All right, you see the red squiggly. Error cannot implicitly convert byte to sbyte. An explicit conversion exists. Are you missing a cast? So the compiler's saying, I could do this for you, but I'm not going to do it for you unless you ask me to or tell me to by using a cast. All right, you can shoot the gun if you wish to. You just have to turn the safety off first. This would get so frustrating to me because I'd build and be like, and fine, I'll throw a cast in, and I knew what was going on, but I really didn't appreciate it, and and it just made me frustrated. But I need to cast it to a signed byte. Of course, I'm going to a signed byte. And well, once I turned the safety off of the cast, the compiler's like, I'll do that. And the thing that frustrated me was, I know I'm only going to use the proper range in here. Okay, and I'm only going to go from 0 to 127. In fact, I'll never go negative, but for whatever reason, maybe I have a function that requires a signed byte or something to that effect. And so just do it. I know it's going to work. And the compiler's smart, and it says, you know what? Probably work for you, Jamie, and in most cases, this will work just fine. But I know there's a range out here, this range right there, that a byte can represent, but a signed byte can't. So if you're going to do this conversion, that's fine. Turn the safety off, and I'll do it for you. All right. And anyway, it was frustrating, but obviously I got over it. And so basically, whenever we look at a type, especially primitive types, we need to consider the domain of that type. And the domain, by the word domain, boy, that sounds technical. It almost shuts your brain off and thinks, oh, he said a mathematical word. I remember that in algebra. I'm going to stop comprehending what's going on here. No, what I mean by domain is, hey, a signed byte can represent negative 128 to 127, right? And that's the domain of a signed byte. And then a regular byte can do 0 to 255. All right, and so if the compiler notices that there's a chance for error, where we could lose some information, then it'll force you to do a cast. Let me just illustrate here. I'm going to come here and say, hey, the number of people in my family is 200. Right? It's a real big family. I'm not even going to try to make a joke on there. So let's put 200 here on the number line. And you see 200 is perfectly or legitimately in the range of a byte, but it definitely will not convert to a signed byte very cleanly. All right? It's not in this red range here, the range of a signed byte. So now the compiler is even more justified, even though it doesn't really care if it's justified or not. And I'm going to turn around and say, hey, convert that to a signed byte. Now what does that mean? I have this value 200 way outside my range. I'm going to force the compiler to do this for me. What's going to happen? Any idea? Pause the video, try to work it out, think it out, and then come back and hit play. Okay, let's try printing this out. Console right lined, signed version. I think we're done with these right lines up here. Drum roll, please. What will print here? Any idea? Control F5, and we get negative 56. So 200. I went from 200 people in my family to negative 56 people. How do you even have negative people in your family? That doesn't make sense. Well, if you're familiar with the binary and the signed way of doing things, let me go to decimal here. I'll type in 200. So 200 in decimal means these bits are turned on and these bits are turned off. All right, and then to interpret this value, however, as a negative value, I have to do the 2's complement trick, which let me just demonstrate here. 1, 1, 0, 0, 1, 0, 0, 0. Okay, so I just grabbed these bits here and drew them down there, and I think we'll come over here, and first of all, to do the 2's complement, we have to do the 1's complement, which means invert all the bits. So the 1's become 0s, and the 0s become 1, like so. And then we're done with this value. Then I have to add 1. All right, well, 1 plus 1 is 0. Carry the 1 plus 1 is 0. Carry the 1 plus 1 is 0. Carry the 1. 1 plus 0 is 1. And then we have these numbers just fall down because it's like adding them against 0. Well, what is this number in decimal? Any idea what that number would be in decimal? You could certainly work it out. But I'm going to do it with a calculator just to show you how to do that as well. Let me clear this out, go to binary, and I'm going to type in, we don't need to type in the leading zeros, but we can do 1, 1, 1, 0, 0, 0. So 1, 1, 1, 0, 0, 0. Then flip to decimal, and hey, there's our 56. All right, so yeah, the compiler said, I'll do that conversion for you. But basically that means I'm just going to interpret the bits as is, and whatever number pops out of that pops out. And so 200 in a 200 200 in binary, if we interpret those as signed, again, refer to the binary videos playlist if necessary, that's the same as the negative 56. So anyway, compiler's cool with us doing that as long as we're explicit. There you go. So my big complaint, though, was, usually I don't have 200 people in my family. I only had, maybe I had 4 or 8 or whatever, and I know I was in a valid range, but the compiler would still force me to do the cast because the compiler knows that not in all cases will this cast work, and so it's protecting us from ourselves.